The first question is what the overall competitive positioning of the firm is, whether it is a technology leader, an imitator, or an efficient manufacturer. If the firm positions itself as a technology leader, it will be R&D intensive. It will allocate its resources quite substantially to basic research. It will enter technology areas and industries in the introductory stages of life cycle. Such firms compete to establish standards and dominant product designs in the industry and therefore let other firms adopt and further develop their innovations. In contrast, firms which position themselves as imitators or followers enter an industry when it is in growth stage or the dominant technologies and product designs are already established. Such firms don't need to allocate much resource to basic research. They invest instead in downstream product development efforts. Their R&D intensity is relatively lower than the technology leaders. A firm that positions itself as an efficient manufacturer may conduct very little R&D and may invest in process innovation and manufacturing technologies. So competitive positioning of a firm determines its R&D intensity, budgetary allocations to basic research and product development, openness, and IP strategies. A firm also decides whether it competes pursuing product strategy or platform strategy. Let me give you an example. Imagine that you are CEO of Apple and you are launching Apple Watch. Again, imagine that 80% of the mobile phones are using Android. Should your Apple Watch be compatible only with the iPhones or iOS or with any Android phones? If you're pursuing product strategy, that is, if you're interested in selling more watches, then you would make it compatible with Android phones because 80% of your potential customers are using Android platform. However, if you want to pursue a platform strategy, you will make the Apple Watch compatible only with iPhones. You will suffer on the sales of Apple Watch, but gain from the stronger competitive positioning of iOS as a platform. So this positioning also determines firms' R&D choices about openness and interoperability. Now the second decision area. What should be the technological scope of the firm? Which technology should it develop and commercialize? This decision influences firms' entry into technology areas and the related budgetary allocation decisions. Secondly, what should be the firm's portfolio of technologies? That is, how will it derive synergies from working simultaneously on many technologies? As you will see in this week's case, Samsung decided to work on 3 emerging technology areas and derive synergies. Further, a firm decides whether it will work on the core technologies or peripheral technologies. Similarly, whether it will innovate in component technologies or product architecture. Let me explain the distinction between the two. So, smartphone was an architectural innovation. iPhone was a new product architecture. The component technologies like display, touchscreen, battery, microprocessors, and telecommunications, etc., were being developed primarily by specialist firms. So Apple's innovation was how it conceptualized a new product and put together these different components. Firms like Intel focused on component technology and innovated in microprocessors. Another important issue is how the firm makes money out of its R&D. Will it operate in market of technologies? That is, will it license its patents to other firms, which in turn create products? Alternatively, the firm can use its innovations in producing new products and creating new processes. So in this case, the firm competes in market of products rather than in market of technologies. The third decision area is where the firm generates new knowledge. Does it conduct R&D inside the organization? If so, where does it locate its lab and R&D centers? For example, if you are a telecommunications company, should you establish your digital telecommunications R&D lab in Hong Kong, Shenzhen, Seoul, Beijing, or San Diego? Does the firm source and deploy the knowledge developed outside its organization? How much open the firm is in knowledge exchange with its environment? Knowledge sourcing decisions also affect firms' organizational design and control decisions, such as the extent of decentralization, formalization, and complexity. In this section, we will learn more about the technological scope of a firm. Three processes, variation, selection, and retention, shape the technological scope of a firm. Resourceful firms invest in variation-seeking innovations. They purposefully support distant search, create technological options under uncertainty, and allow inventors to conduct bottom-up R&D. The next stage is internal selection of technological options. The firm decides which of these are promising or adapted in the industry and should be further developed and commercialized. The third stage is retention of the selected options. The firm decides to adopt the technology officially and deploys organizational resources to develop it further and exploit in the product markets. Let me explain what we mean by bottom-up processes, which is quite common in basic research. In this case, scientists are given a rather free hand to formulate technological problems, form teams of inventors within and outside their organization, and solve those problems. For instance, Google allows its employees to invest some of their time and organizational resources on what it calls moonshot projects, which are very ambitious, have very high probability of failure, and don't fall under Google's technology scope. Competencies and knowledge developed through such bottom-up research initiatives create technological opportunities or options for the firm which its top management had not originally thought about. The firm can select these options or reject them at some point of development. As mentioned earlier, selection is deciding about which technologies to pursue. If the industry as a whole bets on a technology, develops it the most, and it forms the basis of dominant product design, it is an adapted technology. A firm should either select an adapted technology or establish its technology as the dominant technology in the industry so that it has a competitive advantage in the long run. So in 2004, if you were Samsung or Sony, you would like to establish LCD as the dominant technology in digital TV industry. If you were LG, you would like to establish plasma technology as the dominant technology on which you have invested heavily. And if you were a technology follower entering the TV industry in 2006, when LCD already emerged as the dominant technology in the industry, you should select LCD and not the plasma technology. To give you an example, let us go to this week's case of Samsung. We can see that Samsung wanted to position itself as a technology leader and selected and retained three major technology areas: machine learning, AI and automobiles, intelligent healthcare solutions, and intelligent machines to augment human capabilities. Selection error is another very important topic. Inefficient technology selection can have negative impact on firms' performance. We can take the example of Xerox, which produced photocopying machines. It established a basic R&D center at Palo Alto, California, and produced revolutionary inventions in emerging computers technologies. However, the management of Xerox could not realize the value of these inventions and missed out on huge opportunities. I want you to watch this short video, how Steve Jobs got the idea of a graphic user interface from Xerox. So we come to an end of this week's video lectures. In the WBS Live session on Thursday, we will study about the organizational locus of R&D. I also want you to watch a short interview on open innovation, and in the mail I have given you the link of this interview. So see you very soon. Good luck and take care.